Hello, class. The subject I will be presenting to you will be on Internet of Things, cybercrimes. My name is Elijah Kim, and I'm honored to be part of the Cybersecurity Master's Program at CCU. I have been in project management, specifically in cybersecurity, for 4 years and currently working for Capgemini. Since my exposure and involvement in cybersecurity, it has sparked more interest and desire to continue to learn on this topic both from a business and technical perspective. Internet of Things have caught my interest and the willingness to further study on this subject because the increase in demand, accessibility, and convenience it provides to many consumers. Since more people rely on these devices, cybercriminals have more interest in hacking in this sector. For instance, smart homes and offices enable light switches, doors, windows, blinds, and temperatures that can be controlled remotely. This technology creates new security risks that device manufacturers and applications have not anticipated, and user privacy is threatened due to the limited control and choice over collection, retention, and distribution of their data. Now, let's first move on to understand this technology. The internet plays a significant role in the development of Internet of Things. It is a interconnection of various physical devices that collects, control, analyze, and share data in real time. This technology that gives users the ability to connect and check the status of their home securities from their smart devices at anywhere in the world. In other words, the Internet of Things refers to connections to everyday objects to the Internet. As you can see here in this illustration, in the image on the slide, there are several objects that can connect to the internet, such as appliances, vehicles, cameras, and smartwatches within your home. It allows for real-time monitoring and vast data collection, and such data are stored, processed, and can be read by a user from their smart mobile devices or tablets. The increased convenience on these devices offers users comes at the expense of cybersecurity, which we will go more into later in the presentation. Overall, the Internet of Things aims to enhance the quality of life. Gone are the days where you need to vacuum every weekend. You can schedule your smart vacuum to run whichever day and time of the week, or if you're traveling and you turned off your AC, you can remotely turn it back on your way home from your smart device. The motivating factor for the extensive growth of Internet of Things is the most manufacturing industry, service providers, and software industries are investing and adopting more of this technology. The more we see organizations invest and adopt this technology, the more consumers will look to rely on such technology for their personal and home needs. And Figure 1 depicts a graph that predicts the number of devices that will connect to the internet over time. The data was provided to show that in the next 4 years, it's predicted to have 75.44 billion devices connected to the internet. The economic growth of this technology is estimated to range from 2.7 and $6.2 trillion by 2025. The prediction shows the impact of this technology on today's society. In this illustration in Figure 2 provides an overall picture of the diversity of Internet of Things applications. Many are using smart home devices, smart health devices, and so forth. This technology has an impact on most of these applications you see on this slide that continues to emerge and grow as more industries and organizations adopt this technology in their products and offer their consumers the accessibility and convenience. Moving on to common security and privacy threat. Internet of Things device and networks suffer from various type of security and privacy threats. On this page, you see The potential security threats, such as traffic analysis, eavesdropping, spoofing attack, man in the middle, code injection, replay attack, data manipulation, denial of service, jamming, black hole attack, attack, sinkhole attack, tag cloning attack. As you can see, there are various kinds of security threats to this technology, as well as security threats. There are privacy threats to this technology. As you can see on this slide in figure 4, they are identification, localization and tracking, profiling, life cycle transitions, and inventory attack. As you have seen in the previous two slides of the potential security and privacy threats to this technology, Figure 5 illustrates the common privacy and security threats in a three-layer architecture of this technology, with application layer at the top, network layer in the middle, and perception layer at the bottom. The common security mechanisms for the Internet of Things is lightweight cryptography, hardware security, intrusion, detection, and prevention are used to mitigate security and privacy threats in the Internet of Things network. Lightweight cryptography or encryption is a branch of cryptography designed to run on the constrained devices like adequate sensors, smart cards, health devices. It is aimed to provide adequate security to the device, data, network, and application services with the minimal resources requirement of this technology. Hardware security is where the Internet of Things devices are deployed in isolated locations and subjected to various attacks like node tampering, jamming, cloning, and denial of service. For example, emerging areas like the physical unclonable functions can be adopted to enhance the security levels in the Internet of Things. Physical unclonable functions are functions that generate unique identifiers for the devices using dedicated, secure processors during the manufacturing phase and are used to generate secure secret keys. Intrusion detection and prevention is a security mechanism to identify malicious activities by analyzing the data packets in the network layer. For instance, the first phase, the monitoring stage, is to monitor all the incoming traffics into the network. Analyzing stage is to analyze and generate the platform based on the data received from the monitoring phase. And lastly, the detection stage is to perform an anomaly detection or a malicious node detection to mitigate attacks like denial of service. Incorporating these security mechanisms can reduce the risk of any of the security and privacy threats mentioned earlier. To summarize, the Internet of Things connects billions of devices using different communications, technologies, and protocols to provide end users. It provides convenience and accessibilities to a variety of applications. However, it also invites cybercriminals to exploit the Internet of Things infrastructures and networks to conduct large and devastating attacks. As presented earlier of the security and privacy threats to the Internet of Things, the security to mitigate and prevent such attacks were recommended by considering the security mechanisms of lightweight cryptography, hardware security, intrusion detection, and prevention system. These are the references used to gather information to provide you this presentation. This concludes the presentation. Thank you.